Hi, welcome to my home office. This is attempt number 3 to record this video. The first time at school didn't work, and then the computer locked up on me, so let's hope that this time works, warts and all. It'll feel like just like class when I'm having technology problems, right? So anyways, this is part 3, and this should be pretty short. Um, we're going to talk about the aorta and coronary arteries. So most of the things on this page you've already seen. So major blood vessels connected to the heart. The pulmonary trunk is what is also referred to as the pulmonary artery, um, but it quickly splits into left and right. Another phrase for this segment right here, instead of the pulmonary artery, it's the pulmonary trunk, which then splits into the right and left pulmonary arteries. Blood coming back from the pulmonary circuit returns in the pairs of pulmonary veins and they dump into the left atrium. We have the superior and inferior vena cava, or Latin, so that's plural, cava, singular, vena cava, vena cava. You'll hear both pronunciations, but these do not merge before they empty into the right atrium. So you can see the superior has its entrance here on the top. The inferior, shown just right here, you can see, one, see how big it is, and two, see that it comes in on the complete opposite side of the atrium. But then the one we're going to focus most on today is the aorta coming out of the left ventricle. Um, so the first section or segment of it is referred to as the ascending aorta. Then it takes this turn. That's the aortic arch, and then the descending aorta, and it would continue down behind the heart. The descending aorta is sometimes also referred to as the thoracic aorta because that's the cavity that's running through. Once it crosses into the abdominal cavity, it gets referred to as the abdominal aorta. And the aorta stays this diameter all the way down to the basically to the pelvic cavity, where then it splits into two other major vessels. But how do we know where the descending aorta stops and the abdominal aorta starts? When it passes through the diaphragm, the dividing line between the thoracic cavity and the abdominal cavity. But let's focus back to the aorta. We'll come back to the right and left coronary arteries. They're the first things to branch off of the aorta. We'll come back to those on the next slide. So I want to talk about these three that sit right on top of the aortic arch. So the first one is brachiocephalic. The second one is the left common carotid. The third one is the left subclavian. And use the words to help you remember where they're going. Brachio means arm. Cephalic means head. So brachiocephalic is feeding arm and head. And what this vessel is going to do, and we'll see it on a picture on the next slide, is very quickly it itself is going to branch. And one of those branches is going to head out to the right arm. The other branch is going to continue up to the neck and head. The left common carotid, neck and head. Left subclavian, out to the left arm. And this is what those would look like if they were still connected. So we've got the yellow, the brachiocephalic, and notice that it splits. I have lost my mouse. There we go. So the brachiocephalic splits into this little bit bigger branch and a little bit smaller branch. Still not really small, it's just smaller than the other one. So the middle one is the left common carotid and then the left subclavian. Well, what are those branches going to be of the brachiocephalic? Is the right subclavian heading out to the right arm and the right common carotid. So you can see after the brachiocephalic splits, then we do have nice symmetry. We've got on the outside heading to the arms, the two subclavians, and then in parallel running up to the head, the common carotids. Why don't we just have 4 branches all coming off independently of the aortic arch. That's a weird little quirk of evolution that I can't fully explain as to why it evolved that way. Um, so for us, it is what it is. So now we're back to the heart itself. I told you guys a couple classes ago that blood cannot cross the endocardium. So even though the ventricles are full of blood, we that blood does not nourish the myocardium. The blood has to exit the heart and make its way back around the outside, and that's this pattern of blood vessels that we see in order to then come from the outside back in to the myocardial tissue that's doing all the work. So how is that done? Through the coronary arteries. Like I said, the base of the aorta is kind of hidden on the model, but here we can see the right coronary artery exiting out right as soon as right at the very beginning of the aorta. But one interesting note about the coronary arteries is ventricles contract and blood rushes out into all the arteries except the coronary arteries. The coronary arteries fill up during diastole when the ventricles relax. There's a couple reasons for that. The video that I'm going to play in a couple slides, and then actually the two videos that we have at the end of this presentation explore one reason, but the other reason has to do with the heart itself. So I've talked about sometimes like the heart is like a sponge where you're trying to squeeze everything out of it. Well, if you have just squeezed a sponge and you're holding it tight, you can't put a whole lot of water back into it. The sponge needs to relax in order to get water back into it. Well, it's the same thing with the heart muscle tissue. A tense muscle won't accept a whole lot of blood flow coming into it. So when the ventricles contract, you can't force blood into the tissue. It's only when the ventricles relax can we fill the coronary arteries and get blood down into the myocardium. The arrows again indicate exactly where the coronary arteries are. They're just outside the heart at the very, very beginning of the aorta. And that can cause some problems with filling them.
In this video, we'll briefly discuss the coronary arteries and some of their important characteristics. So in this video, we've highlighted the coronary arteries and their veins, and you can see that they take quite similar paths. The myocardial cells receive blood via the right and left coronary arteries, shown here and here. The word coronary comes from the fact that they form a crown around the base of the heart. The base of the heart being here, and you can see that it looks like a crown. The apex of the heart being down here. You'll also notice that very few anastomoses exist between the larger coronary arteries. So if we take a closer look here where the mouse is, this is the major right coronary artery, you don't see any anastomoses. An anastomoses is a branch that comes off one part of the artery and then reconnects at a more distal point on the artery. This is important if an obstruction is blocking the artery. However, with coronary arteries, very few anastomoses exist. So you can see how this can become a problem if there's an obstruction in the coronary artery, such as a coronary thrombosis. This can quickly result in ischemia and myocardial infarction. The right and left coronary arteries are the first branches to come off the aorta being here. So these two coronary arteries are the first branches to come off the aorta. And one important feature of the coronary arteries that differentiate it from other branches that come off the aorta, the aortic arch coming up here and other branches coming off it, is that most branches that come off the aorta fill with blood during ventricular contraction. So when the left ventricle contracts and pushes blood out into the aorta and into the aortic arch, most branches that come off fill with blood. However, the coronary arteries do the opposite. They fill not during ventricular contraction, but during ventricular relaxation. Now let's see how this works. In the picture on the left, the ventricle has contracted and blood is being pushed out into the aorta. So you can see the aortic semilunar valves. Obviously, when the ventricle contracts, the aortic semilunar valve opens. And what it does, you can see in this image, is that it blocks the coronary arteries. So blood is flowing out into the aorta, but it's not able to get down into the coronary arteries. So during ventricular contraction, the coronary arteries are blocked by the opening of the aortic semilunar valves. However, as these aortic semilunar valves close during ventricular relaxation, the right and left coronary arteries become available or visible, and the backflow of the blood down the aorta, which is pressing against the aortic semilunar valve and closing it, also allows blood to flow into the coronary artery. Now finally, because the left ventricle has to pump blood to the entire body, it naturally has to work hardest and therefore requires the largest supply of oxygen and nutrients. In order to explore this 3D image of the heart on your own,
All right, and so I've got one more video, and kind of ignore the bottom half. This has all been merged into one video, but I just want you to focus on the top left and top right. So top left, what are we looking at? We are inside the ventricle. I've got a camera in there, and this is not a living subject, so notice this is nice clear fluid that they're using. But we're in the left ventricle looking up at the aortic valve. Top right, we're on the other side of the valve in the aorta looking down. And what we see here right at the top is one of the coronary arteries. This is going to probably be the left coronary artery. I can't quite tell from the orientation of the camera, but that's probably the left coronary artery. And so as I play and every contraction, watch the valve open and keep an eye on the position, especially of this cusp of the valve in relation to the opening of the coronary artery. Except it happens really fast, really quickly. So notice here as I paused it. So that flap, it's not quite as dramatic as what the graphic was that the guy just showed you. I mean, it's not closing it off. But think about fluid dynamics. That blood is coming out of the left ventricle with some velocity. And so that is a pretty tricky turn to make at velocity around this flap in order to head down this coronary artery. Not to mention the ventricular myocardial tissue where it's going to go doesn't really want to accept it because it's contracted. So that's why it's not until relaxation and all the blood kind of settles back and it would flow back into that artery and fill it on each diastolic relaxation. And so that's it. Your homework is going to be a handout that asks you to label the aortic arch, and then it's got a bunch of other labels of major blood vessels throughout the body. So start working on that. It's the kind of thing just like muscles and bones where I don't need to lecture to tell you which is which. You're going to look at a lot of diagrams, textbook, the internet, pick your favorite resource and start learning those major blood vessels. Most of the diagrams are focusing on arteries, but there's a note on the first page that almost every major artery has a major vein that runs parallel to it with blood obviously moving in the opposite direction. And often they share the same name. Every once in a while, they're not quite the same name. But notice that you're listing your diagrams, there's going to be a lot more arteries than there are veins. But for the most part, they run in parallel. And we can even see that on our heart model, that the patterns kind of follow each other. Um, I will be on my computer throughout the day, so if you've got any questions, feel free to shoot me a message, and don't forget about your quiz tomorrow.